So we're here at the IKE conference, which is in Halle, Germany, Halle an der Saale. And we thought we would take the opportunity because Professor Henrik Svensmark is here and speaking. And so we said, let's interview him about his research and his findings and his experience in looking at climate. Some of the scientific research discussed in this video doesn't agree with the UN's current positions on climate change. To find out more about the UN perspective, we recommend viewing the IPCC reports at ipcc.ch. Willie and I, we've obviously been also looking at solar activity and the potential impacts on climate change. But most of our work has been relying on looking at, specifically, total solar irradiance, trying to identify the trends in the total solar irradiance. And in the climate models, this is typically the way that they model changes, and we have been finding
the broad general effect of the sun, and then excluding stuff that let's say Henrik is working on.
Yes. So the problem is, so within the climate models that the UN Intergovernmental Panel on Climate Change, the IPCC, within their framework, they're relying on climate models, computer models, and they model the solar activity in terms of just direct changes in TSI, total solar irradiance. Now, we've been finding problems with that, but...
And I mean, the change that they are applying is also very, very small, right?
Yes, right? Yes. Yeah. So they're putting it a modest thing, but...
Because that's the reason is that they treat the sun as a problem of perturbation instead of the absolute unit. You know, that the sun is actually doing this whole seasonal cycle that is really large changes. In fact, the largest signal in the Earth system will be the seasonal cycle, actually, in some sense.
I think, Henrik, you first started looking at solar activity and climate. When you went to the DSK, is it? Or when did
a bit of history. DMI, I think he started.
DMI.
Danish Meteorological Institute.
Yeah, I started at the Danish Meteorological Institute, and the reason was I wanted to do something that was interesting.
Right. Yes.
And I was supposed to do something completely different, so I did it in my spare time.
Okay.
So. I had heard the work by Fritz Christensen and Knud Lassen, where they looked at the solar cycle length, and there was a beautiful correlation. And I remember people saying that it was, at the DMI, the Meteorological Institute, that was completely crazy, and so on. But I thought the correlation looked so fantastic that. I started thinking about what could be the origin, and at that time, I think there was some idea that the solar irradiance was not changing so much. So my idea initially was, if it's going to work, it could be that it's clouds that are responding to solar activity somehow, and that, of course. The idea was to look at cosmic rays to see, because cosmic rays are the variable in the atmosphere that changes the most over a solar cycle. Yeah. So that was the initial idea.
Have you ever heard of a name Adam Poulson? Poulson. No. His name appeared in a very famous Journey to the North. The Christian Birkeland, of course, he is Norway, but this Poulson sounded like a Danish guy who actually was already describing, this is in early 1900, of course, the expedition, I forget when, but I took out the book from the Harvard Widener Library. I look into it. By the way, I put some of that into my semi-popular book. I talk a little bit about that. And he was already really was identified about something related to charge activity up there, and then appearance of cloud, by the way. I just want to illuminate that point that of course, you have that insight independently, doesn't matter because history, and you found this thing. It's very exciting, actually. I remember how excited I was. 1996, you guys were doing that DMI preprint because I got the receiver, I received those things, and then I opened up, what the? This is something new. Who's this guy? I don't know who Henrik is because I know Igor Christensen, obviously.
Yeah, that's many, many years ago.
I know. Yeah. I remember the thing around 1996.
So it's 2026 now.
Yeah,
so it's literally 30 years ago.
30 years, yeah.
30 years.
So, yeah, and,
well,
and
give us a summary. Exactly.
that was my, how I got baptized into the cosmic ray stuff, and it was, I had been, working at, I was in Berkeley a number of years and doing stuff there, and then I went to the Nordic Institute of
That's
Theoretical
physics department in Berkeley?
Yeah, physics department, yeah. And they are doing quantum fluctuations and stuff like that. And then I went to the Meteorological Institute, and after we published, that preprint came out, it made such a big fuss. And I remember coming back from a conference in Birmingham where it was presented the first time.
Oh, 1999, I was there.
No, 1996.
96 already, oh, cool.
So it was, I remember coming back, and the headline on one of the biggest in the newspaper was a strong UN critique of Danish researchers. Oh. And that was Bernd Bohlin saying that it was naive and irresponsible to
say such things.
To say that the sun might be important.
So on that, a bit of context for people that are kind of watching is that, so Bernd Bohlin was the chair at the time and one of the founders of the UN IPCC, the Intergovernmental Panel on Climate Change. So the UN in the 1980s had decided that human activity was causing unusual climate change, and in fact the UN Framework Convention on Climate Change defined climate change as any change in the climate that could be related to human modification of the atmosphere.
Yes,
so
a little biased.
Yeah, so there is a kind of a problem because they have a political ideas, and maybe they believed it, and I think many people do, and many people still believe it. But the point is, they were looking at this scientific problem, trying to understand climate change with the assumption that it was human caused. And you, even to this day, people will say climate change, and they assume it's human caused, whereas you were starting to find possible natural factors.
I mean, I can add to that Eigil Friis Christensen, who was, been doing a lot of this solar work also, he went with a delegation to China at some point, and he suggested that one of the IPCC, that one of the larger uncertainties should also be the sun, and they rejected.
They rejected it.
Yeah.
So it's been from the very beginning that the sun was not viewed very favorably by the IPCC simply because they do not want it to be even a relevant factor. That's the question. We simply want to say that, how about the sun? Can we study that? If you want to know climate change, they kind of say no.
No, you can't.
So it's very sad. Yeah. And you find a unique way in which that you think that the climate works that way, right? That is caused by incoming cosmic ray, things like that.
Should I say shortly what it is about?
Yeah. I think you should.
So the idea is that solar activity is modulating how much cosmic rays are entering into the atmosphere, and you can see a beautiful 11-year cycle in the ionization in the atmosphere.
And then inversely related.
Inversely related. So, and therefore, the idea is that the ionization it helps stabilizing small molecular clusters, and these small molecular clusters then can grow to become what we call cloud condensation nuclei. And you, in order for a cloud droplet to form with supersaturation of the water vapor only about 1% or less, you have to have a surface so that they can stick to. And these are the cloud condensation nuclei. And the idea is that if you can change the number of cloud condensation nuclei, you are changing cloud microphysical properties, and in the end, how much energy that the Earth is receiving from the sun.
I Yeah, can I ask one technical question? Because I think people are interested in some of the details. During the time when you were doing this work, I know there was people as soon as they saw your work, I know that a guy I know him personally, Fan Kuan Yu, at University of Albany now. He was a student of Richard Turco at UCLA. They were doing that. But they were the chemistry people, right? They're trying to model how this thing. They immediately know that you have this electric charge. The enhanced nucleation is factor another million, much more efficient than actually neutral product. I think that really immediately got a lot of excitement because that means you have a bit of a physical mechanism in which to have this.
Exactly, yeah. They did some modeling.
Simulation.
Simulations, yes. Yeah. And okay, so in that connection, what we did was we built a laboratory where we made these experiments where we simply tested. We had a huge chamber, and then we put in some gases that mimic the real atmosphere, and then we could change the ionization slightly. So we had changes which are corresponds to what you have, for instance, in the tropics over the oceans. Right. And there we could see already in 2006, I think.
Those experiments.
That when we increased the ionization, the number of aerosols, small aerosols, increased.
Increases,
okay. Yeah. So I mean, without a doubt, there is a physical mechanism.
Yeah, this thing works.
Your ideas have been very controversial. Now, we touched on it, that why it might be controversial in terms to the IPCC. Yes. But the other problem is that what we're dealing with here is, first of all, I think, would you agree that there are many contributing factors to cloud formation, and so you're looking at one specific contribution.
Yes.
And so the difficulty, when I did chemistry, we have a lot of people would look at what's called the rate determining step. And so in chemical reactions, there will be many steps, but oftentimes, depending on the conditions, one particular parameter will be the rate determining step. Now, so one of the ways that I've looked at your work has been that you are identifying that in certain circumstances, the rate determining step might be the amount of galactic cosmic rays that are reaching the Earth. And for those that are not familiar with it, the argument about the galactic cosmic rays is why they're inversely correlated to solar activity, is that when the sun is in a highly active phase, then the solar activity leads to a very strong solar wind, which reduces the amount of galactic cosmic rays coming in. Yeah. And so, am I correct in saying that you are not saying all of the clouds, there's no clouds when there's no sun, the sun is low, and then suddenly...
No, it is a modulation of the cloud.
Right.
And, I mean, we have done a lot of experiments, and of course, experiments have their limitations also. Yeah. And a lot of people, not a lot, but some people were saying that, it might work in your experiments, but it doesn't work in the real atmosphere because, as you say, there are many, many processes. Yeah. And that's why we actually used what we call Forbush decreases. So when you have a coronal mass ejection on the sun, it throws out some plasma, and then over a week it actually screens against the cosmic rays. So you can have up to maybe 30% change in the ionization in the atmosphere. So that we have seen as a natural experiment with the whole Earth, and when these events are occurring, you can then see if anything is happening when you look from other satellites that are looking at clouds and even aerosols also. Yeah. And we actually see a very nice response during these events. So that means that it looks as if this mechanism is working in the atmosphere in spite of all the other processes that are and we can see that it's mainly in low liquid clouds. Okay. It's mainly in remote areas over the oceans, which is exactly what you would expect. It looks as if this change in clouds clouds are responding to changes in cosmic rays.
So they're really interesting papers that you've done on it. So I pronounce it Forbush. How do you pronounce it?
It's Scott E. Forbush from Carnegie Institution.
Okay.
In the 50s.
So I guess to explain to the others, the significance of that is when you have a solar storm, and we had like a very unique one in 2024 in the May, which Willie and I we have written a couple of papers on. But when you have a major solar storm, that's kind of expelling.
Yeah, if it hit the Earth.
That's where you have this.
You end up with a but the effects only last a couple of days.
Yes, it takes about a week for the plasma to move out. So what you typically have, you have a sort of a sharp decrease, and then it goes up again.
Yeah.
And you collected all the statistics, right? Essentially, that's basically the nature of your work, to parallel time with, let's say, some available aerosol data, cloud data, and this and that, right? Remember, you have multiple papers on that one. In fact, you produce even more paper on that than the beginning, the topic, right? I mean, that paper a lot. He done a lot of work on that one.
For good reason, because the Forbush decreases are good in the sense that things are happening on such a short time scale.
Yeah.
If you look at the cloud data over the solar cycle, you don't have stability.
How to measure it?
So you cannot measure it. It's the same with the solar irradiance, I guess.
A lot of superposition kind of data, a lot of short, they're repeatable.
So essentially, what you've done, and this is a something that's kind of unique from the IPCC, or looking at these computer models predominantly, and I'm not described. There's a lot of empirical work in there that is described in the reports, but a huge focus is on these computer models. And then a bit of context is that in the global climate models, the average horizontal grid distances that from latitude and longitude, even the latest models is about 100 kilometers north and south, east, west.
And that's why you can't resolve clouds. And not aerosols either.
So what they do instead is they do what's called parameterization, because like if you just look up into the sky and just try and estimate the size of the clouds, you see, no, these aren't like covering the whole of a country.
Right, no, essentially if there's a cloud, is a cloud that is 100 kilometers by 100 kilometers. It makes no sense. I mean, totally optically thick.
I mean, in Denmark, you might have one horizontal one grid point. But if you look up and look at the clouds, it looks slightly different.
So the thing is, the IPCC openly acknowledge that the cloud, the modeling, even in the computer models and all of the global climate models, because of that logistical thing, is that their grid box is the size of Denmark.
Yeah, you have to parameterize, and that means you have to know the physics, in detail, and you don't.
No, so what you have done is that you have you've built your own laboratory, you've built the things, and you've carried out in situ controlled experiments through your cloud system. And then now there was also, would you like to comment on, I understand that, is it Jasper Kirby? Or
Jasper Kirby, the CERN experiment. Let's not talk about any politics, but can you just summarize for us that what experiment they have done, right? And then CERN. What did they find? That's all I want to say. Well, it must be similar to yours. They built very clean chamber. I know it's very clean. They can down to number of particles. They can really control them well. Because a lot of aerosol people join them. I think they need to.
The thing is that they, what should I say? In 2011, they came out with their results, and they showed that when you increase the ionization, you increase the number of aerosols, which was the same that we found in 2006. And they didn't even reference our work for good reason. I was in the steering committee of the cloud project, And then I can't remember, 2005 maybe, or something like that. And at that point in time, I had a heart attack. I've had a number of heart attacks.
I saw it on TV.
Yeah. And so I was at home, and they had a meeting in Finland. Then I got a call from Finland, from Jasper Kirkby, saying that I was thrown out of the CLOUD project. Yeah. Because the reason that they gave me was that they thought that the experiment I was doing in Denmark was in competition with theirs. Which was completely...
No, it's terrible, because I still remember the day you, me, Eugene Parker, and Jasper Kirby sitting down in Tenerife. I don't know if you remember that.
I remember very vividly.
They were lobbying Gene Parker to... It was very encouraging, by the way. He really likes your work, I know that.
Eugene Parker was very encouraging. He wrote the foreword to their book, yeah. Okay, yeah. So.
Well, maybe a context again, Eugene Parker is one of very distinguished physicists from University of Chicago. Absolutely. He's the only living person that a NASA satellite named after a project, which is a Parker Solar Probe, that go very near. Yeah, he passed away in 2023, actually. He lived very old,
and so then the other thing is that he identified and coined this idea of the solar wind.
Solar wind predicted theoretically.
Yes.
And I think that's also why he liked, at least that's what he said, he liked my work, because when he presented the solar wind, nobody believed that it could be true, and he had so much resistance. Yes. And he was just a young...
Correct. The paper was rejected, and then, of course, Chandrasekhar published it.
So on the solar wind, one of the things, when we're looking at a longer time scale, a lot of people, because you have to go back, the instrumental records of the observation were limited to the satellite era. Then if we want to go back, say even using the sunspots, you're going back to Galileo. But if people want to look at changes in the solar activity going back further, what they're usually relying on are cosmogenic isotope records. Now this is beryllium-10, carbon-14. Yes. And so the formation of these is due to, it's not direct measurement of the sun, of the solar activity. No, it's an indirect measurement of what they're seeing is when the galactic cosmic rays activity reaching Earth is high, it's indicating the solar wind is probably weak. And so it's an inverse, so it directly ties into you're looking at this as a potential mechanism.
So yes, I like the cosmic isotopes, of course.
Right, it's an extra neutron that we need.
So you've looked at in your work, you've looking at very short time scales. You've looked at the laboratory and you're doing in real time doing these experiments, but then people correctly argue, yeah, but that's in a controlled experiment. What about in the real world? Yeah. So then you've taken this other point where you're saying, oh, well, we have these natural experiments that you can't control, but they do occur, and you can look at particularly at the very strong ones, and then see, does this have any impact at all on events? And you're saying that you are finding results now.
It seems very consistent now.
Yeah. So what you're saying is that you are identifying a mechanism for a climatically relevant factor, which is that you're suggesting that it seems to increase in certain conditions. Certain cloud formations are more likely to occur when the solar activity is weak versus when it's strong. Now, if that was the only factor, then you would look and you would say, wow, solar activity, you'll get massive amounts of clouds that will then lead to cooling. And initially, I think in some of your early work, you were using other people's satellite observations of cloud cover, and you found what initially seemed like unbelievably, like it was a very strong correlation, but then over time...
on the 11-year cycle. Yes.
But over time...
I mean, when we discovered the first data, they had a very beautiful correlation. Yeah. Then around 94, and the data after that from what's called the ISKIP data set, There, it was quite clear that something happened with the what we call
The satellite platform.
calibration.
Drive and all those
I mean, there was something with the calibration at that time. So we tried to modify it so we could get it up to 2006. But after that, it was clearly that something strange was happening. And then when you start comparing with other cloud data set, then they have all slightly different, just like everything else that is difficult to measure.
Yes, it's a problem of basically data product. They need to assimilate all the radiance thing into a model of some sense. Actually, maybe just cut it short. I do want to raise one very important point that I thought I will hear your opinion, but I want to summarize it first. It's, sometimes I think for skeptics who are not knowledgeable, it's not correct to say that IPCC will say that. It's not correct to say that we haven't included the cosmic ray cloud in the climate model. They did. No, they did. Sorry, they did. No, they say they included in the model. Yeah. But if you look carefully at the 2-3 papers that they have, that they run some of the NCAR models.
Yeah.
The parameterization in which they put in is just laughable, okay? It's not serious attempt of what you describe in your empirical data. That's why I find it really troublesome. You see, it's a bit of what you call preempting. They want to make sure that you cannot make that statement that they don't account for this effect. They actually are doing a fake attempt. They are not serious. Do you understand? When you want to reject hypothesis, you got to do the best you can, giving you maximum the benefit of the doubt that you are right, for example. I really want to hear your perspective on that, because I know it's a hard problem. Cloud is indeed the unsolved problem of climate, I would say, right? Yeah.
I mean, it's absolutely true that the argument that has been used to say that what I'm doing is not worthwhile is based on these chemical transport models mainly. When you look at the IPCC report and what they write about this, they're very dismissive of what I'm doing. So the way they write it, I don't know if you know, but you had the climate gate at some point.
Correct. You found some stuff in your...
Yeah, so in that there was some discussion who should be the new authors of this section, and then they were suggesting various people, and then they said this guy is qualified, parentheses in a bracket, anti-Svensmark.
Oh, okay.
So and the guy that they got to do it, he was, really against what I'm doing.
The one that got selected. Yeah.
So
do you remember the name of the guy?
It was, I think it's Benjamin Laken.
Oh yeah, I know Benjamin Laken. I know. Yeah, they are the one that published those kind of papers.
They wrote a paper.
English, I think they're from England.
He even published a paper called the late cosmic ray theory or something like that.
So for people who are not familiar with the IPCC process, the IPCC, they like to pretend that they're the definitive gospel.
And also inclusive. They allow everybody. No, it's not true.
On climate change. But if you actually read their remit is to identify, to describe for policymakers and people the climate information that would be of relevance to policymakers. Now, so your information that you have found, your scientific information that you are finding, was apparently not suitable for the goals,
and still not is.
Yeah. So in the IPCC, they do cite your work, but there is a lot of papers back. There's a lot of papers back and forth. No, because we've found the same thing. Is that what they'll do is they say, but you didn't mention Professor Svensmark's work, and then they say, oh, okay, we have to mention it. And then but we don't want people to be thinking it. So they say, has there been any study that is contradicting it? And then it's like, oh, here. So now they put that as being the definitive one. And then if you have a response, no, that's not important. We just go with the one that showed that Svensmark's
that's saying anything negative. That's not how science is conducted.
I mean, some of these works on Forbush, I think we spent almost 2 years to get them out. And then the rebuttal, it took 6 weeks.
There have been others though that have been supporting your work. I'd say, like Willie, you've sometimes criticised some of the papers, and others have been. There's been some papers that have said this is supporting your work, and then others that are saying this supports some of it but contradicts others, and then you have others that are criticising it. So it is a bit of a mess. It's a complex thing. Yeah. But I think it might be worth mentioning that the Jan Veizer and Nir Shaviv, that they kind of. Can you say a little bit about where they came from?
Yeah, but I mean, then we start talking about some completely different timescales,
yes,
right? So
yes.
we're on geological timescales, yes. And it has to do with astrophysics also, yes. Which is also your field. So the idea is that the cosmic rays, they come from actually when you have star formation and you have big stars, they explode. And then they can accelerate these cosmic rays. So star formation, in some sense, is exploding stars is the source of cosmic rays. And then when the solar system is moving in our galaxy, it's moving around the galactic center. It gets in and out of regions where there's more or less star formations. And when you have a lot of star formation, typically in the spiral arms, you will have a much higher, and it's not just, this 10, 20%, it's, 300% changes.
Yeah. Big factor, yeah.
So it's a big factor. And Jan Veizer and Nir Shaviv did some work in 2003, I think, where they showed that the large glaciations that we have had in the Earth's history fits beautifully with the passage of spiral arms.
Okay, yeah.
So you had this, completely fascinating connection.
So their theoretical framework for doing it is that, like, when you have periods of higher galactic cosmic rays, then this shouldn't necessarily influence the solar activity, but it should influence your effect, because there will be an extra...
You can say it's independent of solar activity as such.
So I think you also looked at, did some work on that longer time scale, looking at supernova.
I also did a lot of work, and I did it for a period because I thought by doing long time scales I would get out of all this CO2 stuff.
Oh, correct, yeah.
But it doesn't work that way, because
it doesn't work, you're right.
Like Jan Veizer, he has been one of the top geologists in the world, right?
Yeah.
And everybody's been using his isotope data. But after he made that paper saying that climate on Earth was not correlated on geological timescales with CO2, he was vilified in a way you wouldn't believe, and I think he's been suffering from it ever since.
Well, what about yourself? Because you mentioned that you said, oh, maybe I can step away from the fire by looking at things on a longer time scale, and you're saying it doesn't really work. But I thought that, that if you are disagreeing with the CO2 narrative, that you will be inundated with lots of cash from the fossil fuel industries who love your work. And so,
have you categorically denied that you have received money from fossil fuel oil company?
I don't think I ever received a dime.
A dime from them, You only pay them because you put gas in your car. You only pay them.
So has this been helpful to your career, to follow to follow what you believe the science is pointing to?
Oh, it's been very, very strange. It's been, first of all, I should say I'm extremely happy that I've been able to do the science, because the science is really, really interesting. But my situation has been horrible over the years, and. There's been so many things, and you have been through
we similar kind of thing, but maybe different level. Yes,
exactly. So In 2016, the rector of the university, he demoted me from professor to a lower rank. So, and then I could be fired much more easily.
Easily, yeah.
So in 2021, they tried to fire me, but I got the help from Linsen and Will Harper. Yeah. So they wrote, and also Nia and some other people from Princeton wrote some letters to the rector and so on. So they didn't fire me, but they took away my salary.
Oh, no.
So I didn't have any salary, so I had to find my salary, most of my salary actually.
Okay.
And now in 2026, 14 days ago, I was fired.
Oh, no.
So I'm fired.
So you're officially out.
Oh, no.
But I do want to ask questions. Sorry if I keep asking questions. If you don't say anything, it's okay. I see another Svensmark name. Is that your son?
That's
on
my
your
son, yeah.
Oh, cool. Yeah. He's still not scared, right? Well, terrible. I laugh because, man, he believes in science like you.
But his problem is that he has the same surname.
Yeah, same surname. So he's already criticized.
So he has not been able to get a job.
Job too, yeah.
So he's now teaching in high school.
High school, yeah. Okay.
If you had gone and said, hey, I'm now debunking the cosmic rays and it's all due to carbon dioxide, what would have been the path there?
It wouldn't be me, but I don't know if they would take me serious. But I mean, we have seen many people who have converted, and they have been embraced to some extent. But I always find this a bit silly.
It is very sad because Denmark is really the home of Niels Bohr, besides news of Carlsberg. I mean, these guys are really serious people who fund science and really want science to be a priority.
I mean, there are some good traditions. There are good traditions. But and many people, when they talk about science, no matter who they are, they say the right things. We use the scientific principle, and that we should be open to new ideas, and we should be critical, and so on. But then, in reality, they are, narrow-minded, and they censor any other subject that they don't like.
Can you believe that?
So there's nothing new.
Sorry, not laughing, but it's bad.
Yeah, no, I'm sorry to hear about that, and it's kind of what we've been, the team that we have been.
This is why I decided to go our academia completely. Trying to see we can do a very independent way of what you call nurturing science. We're not able to fund science because there's just not enough funding.
The problem is funding.
Yeah, because, of course, yeah.
Because in order to do science, you need funding.
Yeah.
And that's the reality. And then it's like, but here's do you think that if governments and the public were not so interested in climate change and they were looking at something else, and like you can see some people are, like Bill Gates is now promoting
geoengineering,
and also looking at nuclear and trying, because he's no longer concerned.
He needs the current.
He needs the data centers. Microsoft need the AI data centers. But imagine if there was like this, the future. If in a parallel world, you had just started your thing, but the people were not concerned about climate change, what would have you would have been interested? Would you have been interested in the subject?
Yeah, I think it's really interesting. I mean, one of the things I didn't discuss here is my work on the long time scales, which has gone a lot on the long time scale, the geological time scale. Because the climate changes are so large that I see beautiful correlations with the conditions for life. On Earth, and I'm going to just show you some of that tomorrow, but I'm not going to.
Keep it down.
So
this is what you're trying to do, is trying to understand the context
and if this is true, it means that processes that are completely remote from the Earth, which has to do with star formation, is actually giving conditions for life. here on Earth.
Professor Svensmark, thank you for taking the time. This has been very interesting, and I think we covered a lot. And we're really sorry for what you've just recently gone through, and we hope that you can find somebody, because
thank you. I hope to continue my work somehow.
I think anybody that's watching this or whatever and is thinking, hey, let's do science. Why don't we just investigate and make a discovery? I think hopefully you can kind of see why it's not always so simple. And actually, if you want to do science and you want to follow science, well, here's the problem that I've noticed is if you are doing science that is in a politically charged topic and you are following the science, well, then your results will end up being politically incorrect because you're not following the politics.
Exactly, yeah.
But if you are interested in science, which you clearly are, and we are as well, then you want to see the science. And so,
I mean, the thing is, if you're a real scientist, you follow, what the science goes.
Okay, so thank you very much for taking the time.
Thank you so much, Henrik.
Thank you.